Good morning, all of you. This is O.Sailaja, lecturer, Department of Chemistry, K.B.N College, Vijayawda. Today, I will discuss about some synthetic reactions in our syllabus. First of all, I will tell you about the Shapiro reaction. This Shapiro reaction is the well-known organic reaction. Shapiro reaction was first introduced by the Robert H. Shapiro in the year of 1967. In Shapiro reaction, it is an organic reaction that leads to the formation of, it is mainly used for the preparation of alkenes. By the simple, we treat with the tosyl hydrozones with the cardinal compounds. The cardinal compounds either aldehydes or ketones. On treatment with the tosyl hydrozones with the strong base gives the simple alkenes. It can be used to alkyl lithium and Grignard reagent and effortless substituted alkenes. Here, tosyl hydrozones simply on treatment with the alkyl lithium compounds, it is converted to the simple alkenes. And here also tosyl hydrozones converted to the alkenes. Here also tosyl hydrozones are converted towards to the simple alkenes. In Shapiro reaction, mainly we can prepare the simple alkenes on treatment with the tosyl hydrozones with the carbonyl compounds with the strong base. And next of all, Stark-Kahneman reaction. In Stark-Kahneman reaction is the alkylation of cyclic ketones. Cyclic ketones on alkylation in the presence of pyrrolium via the formation of enamine is an intermediate. Simple cyclic ketones on treatment with the pyrrolium. Here, the formation of enamine is the reactive intermediate, and this on treatment with the alkyl halides. Further hydrolysis to use the substituted cyclic ketones. Cyclic ketones on treatment with the pyrrolidine, it gives the simple enamine, and it is converted to the simple cyclic ketones, that are the substituted cyclic ketones on alkylation with alkyl halides, and further hydrolysis it gives the substituted cyclic ketones. Here cyclohexanone on treatment with the pyrrolidine, it gives the simple enamine as the intermediate. This on treatment with the methyl chloride gives the substituted cyclic ketone. Next up, Wittig reaction. It is also well-known synthetic organic reaction. It is also used to prepare the carbon-carbon double bonds that are nothing but the simple alkenes. Here we prepare the simple alkenes. Wittig reaction is a chemical reaction in which cardinal compounds that are the aldehydes or ketones on treatment with the phosphorus violates it converted to the simple alkenes. This is useful reaction to convert the aldehydes and ketones to give the simple alkenes. In this reaction, Wittig reagents reacts with the cardinal compounds. This is the phosphorus violate that is used as a Wittig reagent that reacted with the simple cardinal compounds who gives the alkenes, and triphenyl phosphine oxide as a side product. Simple cardinal compounds that are the aldehydes or ketones. Here we have the ketone on treatment with the phosphorus violet. It gives the simple alkenes by the removal of triphenyl phosphine oxide as a byproduct. Mechanism of Wittig reaction. In the first step, cardinal compounds react with the phosphorus violet to form a dipolar intermediate, that is the betaine. Okay. Cardinal compound and treatment with the phosphorus violet to give the betaine as an intermediate. Then betaine is converted to the another intermediate which has four-membered cyclic transition state. This is the 4-membered cyclic transition state. Okay. By the simple rearrangement of these bonds, sigma bonds, to give the alkenes and triphenyl phosphorus oxide as a byproduct. Next of all, Heck reaction. This is also well-known synthetic organic reaction. The Heck reaction is the palladium catalyzed cross-coupling reaction. This reaction is catalyzed by the palladium. Okay, we know that the catalyst, what is meant by catalyst? The catalyst is nothing but the reactant or the reagent which is used to increase the rate of the reaction, but it does not involve in the reaction, that is said to be catalyst. Here we use the palladium as a catalyst. The Heck reaction is a palladium catalyzed cross coupling reaction between the simple alkenes and with the organohalides or vinyl halides or aryl halides to give the substituted alkenes. Okay, here we have bromobenzene. On treatment with the ethyl benzene, we get the simple coupled product. Next of all, Suzuki coupling. The Suzuki coupling is the coupling of aryl or vinyl boronic acid with the aryl or vinyl halides. This is the boronic acid on treatment with the aryl or vinyl bromohalogens, bromo compounds in the presence of sodium ethoxide as a strong base. We get the simple substituted alkenes. It is a powerful cross-coupling method to allow the synthesis of conjugated olefins, styrene and biphenyls. In this reaction, we get the styrene compounds, that are the alkenes. Simple, we have the ethyl chloride on treatment with the simple phenyl boronic acid. Vinyl halide, ethyl halide. This is the vinyl halide. We know that on treatment with the phenyl boronic acid by using the catalyst palladium in the presence of solvent dichloromethane to give the product styrene. Here also another example, 4-bromoacetophenone on treatment with the phenyl boronic acid in the presence of palladium catalyst and the potassium carbonate as a base. Finally, we get the 4-phenyl acetophenone. This is the biphenyl group. Okay. The coupling of two aromatic rings takes place in this reaction. And next of all, Negishi coupling. In Negishi, cross-coupling reaction is an organic reaction of organohalides with the organic zinc compounds. Here, organohalides on treatment with the organo-zinc compounds, we get the simple alkanes. Here we prepare the carbon-carbon sigma bond in simple Negishi coupling reaction. The reaction couples the organic halides or triplets with organo-zinc compounds to form the carbon-carbon bond in this process. Simply coupling of simple alkyl halides on treatment with the organo-zinc compounds to give the carbon-carbon sigma bond, that is this alkyl group is coupled with this alkyl group R1 R2. Simple alkanes can be prepared by using the Negishi coupling. Here alkyl halides on treatment with the aromatic zinc chloride. Here zinc chloride can be eliminated and this aromatic group and this aromatic group can be coupled to each other to form the biphenyl benzene. And last reaction, Stille coupling reaction. Stille coupling reaction also catalyzed by the simple catalyst palladium. The Stille cross-coupling reaction is the organic reaction of organohalides on treatment with the organostanates. We get the fused products or coupled products, that are the alkyl groups are coupled to each other. This R1 alkyl group is coupled to the R2 alkyl group. We get the coupled product. That is, we can prepare the simple carbon-carbon sigma bond. This is the well-known synthetic organic reactions to prepare the CC sigma bond in these reactions. The Stille cross-coupling reaction is the organic reaction of organohalide with the organostanate compounds to give the coupled product by using the catalyst palladium. Here, X is typically, we know that the halide that are nothing but fluorine, chlorine, bromine, iodine. Additionally, X can be pseudo halide such as triflex. The reaction is usually performed under the inert atmosphere. Here we using the halides. So it can be prepared by using the under inert atmospheric conditions by using the dehydrated and the degassed solvent. Finally, we get the coupled product. Here, aryl or vinyl halides on treatment with the organostanates, this alkyl group is coupled with this aromatic group. We can prepare a simple carbon-carbon sigma bond by using Stille coupling reaction as platinum as catalyst. Thank you.